Welcome to KCC Diesel Online. My name is Jeff Rush, and this is DST 115. Today we're going to cover Chapter 10 on troubleshooting and performance testing the AC system. So we need to identify the proper safety equipment worn when servicing HVACR systems. Explain how to safely work on the pressurized HVAC system. List the rules that should be followed whenever a system has been opened to the atmosphere, and explain the performance test of the HVAC system. Now, we've been covering this for a little over a week, so most of you guys have learned a lot of these lessons. So we're not going to go over this in depth. Again, I'm going to lean on the prior experience, the prior lessons we've had. So this may not be as in depth as you might expect it to be if you weren't in the classroom watching my other lessons. All right, learning objectives. Identify the system that contains some air, moisture. Identify a system that contains some air and moisture. Identify a system that has excessive air and moisture. Identify a system that has restricted airflow through the condenser and is overcharged. And identify a system that has a low refrigerant charge. Identify a system that has very low refrigerant. And a couple of us, we've seen this a couple times in the shop, where that rule of thumb measurement of the ambient air in degrees versus the pressure in the manifold gauges, that rule of thumb doesn't work. And I think that's what we proved in the shop a couple of times, where there's 80 psi in the gauges right now, but that is just an indication that there's pressure inside the system and not that it's refrigerant or that that's a normal charge. So don't trust that. I think that's the lesson we've learned. Identify a system that has a restriction in the high pressure side of the system, and identify a system that has a TXV that will not open. Identify a system with a TXV that is held open. Identify a system that has a defective thermostatic switch. Identify a system that has a defective compressor. Identify the difference between purging and flushing an AC system, and list the procedures for purging an AC system. Explain the procedures for flushing an AC system, and explain how to pop dry a system after a full flush has been performed. All right, caution. Air conditioning systems are always under pressure. Before internal repairs are made, refrigerant must be recovered from the system. Once repairs are complete, the system must be evacuated, recharged before it can be returned to service. Remember, even if the customer comes in and says, I don't have any AC, my uncle, drained it or opened it up to atmosphere, assume that some pressure may build in there, residual refrigerant in the desiccant that can leak out, air that can build up pressure inside the system. Don't assume that there's not going to be some pressure in there. Even if you yourself are the one that evacuated that system, we find oftentimes that the pressure can build back up again. That's why we do that 5-minute recovery period after we've sucked the system down into a vacuum. We wait 5 minutes to see if the system bleeds back up. And so that's what we're looking for there. So be very careful when you open these systems that there may still be some residual pressure in there. All right, air conditioning safety. Safety glasses, non-leather gloves, proper ventilation. Refrigerant must be stored below 125 degrees Fahrenheit. Refrigerant oil must be stored in airtight containers, and do not mix refrigerant oils, such as ester and PAG. We don't mix them. When the system is open, cap disconnected lines. So as we're servicing this, we need to cap the lines. Replace and lubricate all O-rings on all disconnected lines. Replace the receiver dryer or accumulator on open systems. Keep the manifold gauge set connected when servicing, and replace all lost refrigerant oil. So we've dealt with this where people aren't paying attention when the machine starts to tell you to, watch the oil, you really do need to take that before and after measurement so you know where your oil was in that reservoir before it adds oil. And as a rule of thumb, if I don't get much refrigerant oil out of the system and I'm adding dye anyway, I will add dye with 1 ounce of oil. That's just been my preferred practice for a long time. So again, right, wrong, or otherwise, that's my practice. That's how I do that. That way, when I'm adding my dye, and we've dealt with this in class with our oil injector, adding 1/8 of an ounce of dye doesn't give the dye much medium to move around in the system. So if your system is a little dry and you add that dye, you want that dye to migrate throughout your system to find where it may be leaking. And so adding the dye with a little oil helps to have a medium for the dye to travel inside the system. All right, servicing continued. Prior to any service work that is performed, talk to the text here is a little weird. Prior to any service work that is performed, talk to Drive to obtain any problematic history of the unit. I think what they're trying to say there is talk to the customer, talk to or drive the vehicle to obtain any problematic history. The questions that you talk to the customer about should include, did the AC fail all at once, or did it gradually lose its effectiveness over years or seasons? Does the AC work occasionally or not at all? And has AC work been performed on it, or has it been serviced recently? All right, performance testing. So, rule of thumb here between all of the different companies, we're going to run the AC at 1500 RPM, close all the windows. Now, some companies may say open all the windows and doors. So please follow your manufacturer's instructions when you're doing this. Otherwise, your readings may be a little skewed from the manufacturer's. Run the AC on max for 10 minutes to stabilize the system. Insert a thermometer in the air vent, and sometimes that air vent, they want it in the closest air vent to the evaporator. They'll tell you to close the other air vents. So again, follow the manufacturer's instructions to the best of your ability. Let the system stabilize. Check for proper vent and fan operation. So again, whenever we're doing this, we want to do a complete function check. Play with it, make sure all the blower motor speeds work, defrost, floor, panel, floor panel, just all the different combinations you can think of. Make sure that everything works in conjunction with each other. Visually inspect the compressor and the compressor clutch and drive belt. Feel the suction and discharge lines at the compressor. The suction line should be cold and the discharge line should be hot. Be careful. It actually could be hot enough to kind of burn you, so make sure you're not just grabbing a hold of it, blatantly with your hand and not knowing that it would actually be hot enough to burn you. Feel the condenser inlet and outlet. There should be a large change in temperature. Feel the condenser to feel the condenser to dryer line. Feel for warm and cold spots. What you're looking for there is, any restrictions, any unwanted pressure drops, any unwanted resistance. Feel the inlet and outlet of the receiver dryer. They should be the same temperature. Feel the outlet of the receiver dryer to the TXV line. It should be a consistent temperature. Feel the suction line from the evaporator to the compressor. It should be cold. If the engine is running hot or the heater water valve is stuck open, the system will not cool. So here's another one of those things that we need to talk about. Some systems are very dependent on making sure that hot water valve is off, and we've talked about that in class. A lot of systems have a vacuum operated shut-off valve, hot water shut-off valve, and that needs to be, that needs to work in order for the system to work properly. Check the discharge air temperature. It will vary depending on the ambient temp and the humidity. And then shut the unit down and feel for cold spots indicating restrictions. All right, so a lot of manufacturers are going to have a flow chart like this, Okay, so from insufficient cooling, let's go ahead here. Watch my cursor. Insufficient cooling. Check airflow. No or low airflow or normal airflow, and then we're gonna branch off from there, and then just go through the troubleshooting tree. That's an overview of the diagnostics, and oftentimes they have more specific diagnostics, but this is the flow chart they have for this particular example. All right, here's our manifold gauge set. We've talked about this. We've probably done it in class by now. And you're hooking this up high side, low side. Blue gauge is the low, red is the high side, and we're going to go ahead and hook these up. And then obviously, be careful because the lines can be fragile. You don't want to break the lines. You also don't want to have any kind of frost burns from not wearing gloves. So make sure you're wearing the proper PPE for this.